So, okay, just start off.
Okay, you said Yeray?
Yeah.
Yeray.
Don't
okay.
worry. That's fine.
Okay, let me introduce Yeray. His talk today is Import as an Anti-Pattern. Let's give him a big warm welcome.
Hey, thank you. So yeah, I'm here to I'm here to talk about dependency injection, which is one of those things that it was a really aha moment for me when I actually realized that it's a technique that can help you think about object-oriented design and how you apply these things and the benefits that it kind of brought home a lot of concepts that were just like, in the air, and they really connect for me. So first off, a little bit about me. I'm Yeray. I'm from the Canary Islands. That's the weird name spelling. I'm a freelancer software engineer in London. I'm also a co-organizer of the London Python meetup, along with Gil, who's you've seen here the guy, and Simon and Patrick. And I'm also a moderator and a contributor for PyPI.org. So contact me if you want to speak at one of those on London Python meetup, or if you have problems with naming classes on PyPI like Martin had, which there's actually a pet for it. It's my favorite pet ever. I'm not going to bore you with details. Anyway, I was sort of researching for this talk, and I have, the title's pretty clickbaity. That's on purpose. There's a reason for that, but I actually had a different title in mind. It's Dependency Injection, worst name ever. Because it just sounds scary. It's like you have these dependencies, and you inject them, and in the tech world, injecting things is bad, right? We all know about this. So I wanted to know what my fellow Python developers think about dependency injection. So I went to Twitter, obviously, and I went and pretty significant negative reaction over there. But obviously, the sample size wasn't inclusive, right? So I wanted to ask you guys, and since there are so many of you, how does dependency injection make you feel? So as a quick show of hands, how many of you know what dependency injection is? Okay, that's about 30% of the room, roughly. So if you can, again, show hands of people that actually use dependency injection in any language at all. A little bit less, basically all the other ones. So then, how many of you have used it in Python? A little bit less. How many of you have used it in Python successfully? A little bit less. So I like to kind of bring home how you can use it in Python and the benefits it actually yields from it. So let's see some code, because we're all safe in code. Imagine that you have this task that you've been given, where you say you need to compute the MD5 hash of a series of files that live in Google Cloud Storage, right? Pretty simple stuff. You go, you tap, hack, and you go and get something like this, right? You have a file processor class that takes a resource path and creates a client using the Google Storage library. It authenticates it with the credentials and creates a bucket, and then it has a method called run, And when you call that method, it fetches all the blobs from a bucket and processes them. And when processing just means downloading the contents into bytes.io and computing the MD5 hash. That's fairly standard. We've all done something like this. It's the beauty of Python and PyPI, right? So obviously, as good developers that we are, we want to test this. So I'm going to give you a couple of seconds to scan this test code. This is standard test code, I believe, in Python. So as you look at this, you're probably going to, I did this. I do that all the time when I write tests like this. It's confusing, right? Let's break it down. What exactly is happening here? So you're mocking the actual storage library. That's the first step, pretty standard. Then you're mocking the bucket attribute of the file processor. Then we create some convoluted mocking and functions, and because what we want to do is mock the download to file blob method on the blob. And then we mock the list blobs to return a list of that single blob. Okay? Weird. And eventually we go into this run, we actually call it, and we actually assert that things are running. So why is it so complicated? Why is it so hard? So if you look back at the application code, we have this let's just list the dependencies here, right? There's a dependency here on the storage library. It has to be installed in your virtual env, hopefully. There's a dependency on the application's credentials path, like that is a runtime dependency that has to be there. Then you depend on the class method from service account JSON on the client. Then you depend on the getBucket method on the client. Then you depend on the list blob. See where I'm going there? There's a lot of methods there, a lot of dependencies. And then you depend on the blob download to file method to actually get the context that then you can feed into the MD5. That is what we call coupling. Your code is exceptionally coupled to the Google Storage Library. There's a lot of coupling going on. So where did it all go wrong? What happened here? This. You imported the storage library. I know it sounds weird, like, but this is, just bear with me. That's what I say the import is an antipattern, which is probably, again, a little bit clickbaity. But the point here is that the moment you import that into your module, you're forcing yourself to work with that API, whatever it may be. And why did we actually do it? So what is this accomplishing for us? What's the responsibility you're fulfilling here? The responsibility is getting files from a cloud provider. That's all it does, right? We're getting files and we're computing the MD5 hash. Those are two responsibilities, right? What if we could somehow not do that? What if we could remove that responsibility from the file processor entirely and just like with something, whatever, we don't really care. Something abstract, right? Like maybe an abstraction, because we like abstractions. There's a saying, it's a principle that says depend on abstractions, not concretions, right? So in Python, how do you actually, well, first off, let's define what an abstraction is. So an abstraction is a formal interface definition and a series of objects that implement that interface, right? And those objects kind of encapsulate all the low-level gritty details that, as we just demonstrated, we need to implement. But, if we abstract them away, maybe it's easier. Let's have a go at that. So in our case, and as you know, in Python, to create interfaces, there's a couple of ways, but in the standard library, we have abstract base classes. So in our case, it would be something like this. We're creating this abstraction called file repo. And it has a single method that just get files, like I mentioned. That's the responsibility, that's it. This method just takes a path, which was the resource path in our original code. And, since we all saw Dustin Ingram's static typing talk, we did, it's on YouTube, you should watch it, it's great. We can get this and expand that and actually have more details on our abstraction. So you can actually put the type path is as a string, and it returns an iterable of bytes IOs, right? I think that's exactly what happened before, and it's very well formalized now. And the good thing about it then is that now that it's statically typed, MyPy and all these lovely tools that Dustin was talking about can actually make sure that you don't shoot yourself in the foot with this. You know exactly when you're actually abiding to the rules of the interface. So how does that affect our file processor class? So we import the file repo abstraction. We pass something that implements the file repo abstraction, and we just call get files. You probably agree with me, this is a lot simpler right off the bat. We still process the files because we're getting bytes IO from it. We know we're getting bytes IO from the concrete implementation of file repo. So this right here, you see that massive green arrow? That's dependency injection. That's all it is. It's passing something that the dependency, something that encapsulates dependency to the actual class. There's nothing special about it, there's nothing magical, but it has quite serious consequences to this. So what is something that implements the file repo class? So here we have the GCS file repo. So this thing is effectively implementing the file repo abstraction in a very concrete way, specifically for Google Cloud Storage. And you can see there's a lot of the same that we were doing in file repo class. We instantiate the client, we get the bucket, blah, blah, blah. But in the get files method, we use all that stuff and yield that bytes IO. So taking a step back and just doing diagrams, because diagrams are cool. we had the file processor depending directly on the Google Storage Library, right? Direct relationship. What we just did now is we have a file processor that now depends on the abstraction, and the GCS file repo is implementing that abstraction. This arrow here that goes upwards, that is inversion of control. It's powerful concept, and it's something that dependency injection is a way of achieving. It's a very direct way of achieving, and actually David has a talk about in Inversion control that he did in London Python a couple of months ago. And there's other methods, but dependency injection is a very obvious way of doing this. So specifically in the code, what happened is the file processor no longer has two responsibilities, it has only one responsibility that must be ringing some bells in your brain about good stuff and good practices. And there's also something very subtle here. The file processor no longer instantiates the repo. That's not his responsibility. It's been given that instance of the repo. That is coming from above, from the caller. So if you follow that idea further on to its ultimate conclusion, there must be a way, there must be a point in your program that takes all the dependencies, instantiates them all, and handles them across, creating what is known as a dependency tree. That point is the composition root. And it's usually, obviously, you can imagine it's at the very top of the call stack, like at the entry point of our application. So in our case, it's a simple example. We have, this would be the composition root, which is basically the entry point to our application. It's just importing the file processor, importing the concrete implementation of it, and just a function where we actually instantiate the repo and we pass it to the file processor. That's simple enough. So what happened here? What are the benefits of actually doing this? Because there's a cost here. There's a cognitive cost of creating all that. There's new files, new interfaces. All of this must, hopefully, yield some benefits. So the first one is interception. And interception comes from the fact that we're as callers of the file processor class, we are in control of what comes into it. In that case, we can intercept what's going into it and change it for something more simpler. That would be cool for tests, right? And that's what you actually have to do. Like the test for the file processor class is simplified greatly because it just needs anything that actually implements the abstraction. Here I'm using specking, mock specking, which is something, a feature in mocks that will yell at you if it's not abiding to the abstraction, but just as easily you can just use the actual class and just pass it in. It's just a thing that returns these two bytes IO full and bar, and you can just run the file processor with that. That's much simpler than we had before. That is the list substitution principle. Again, another thing that you've read about, well, at least I read it. Maybe everybody understands this one, but that took me a while to understand. That basically means that you can substitute two things of the subtype. You can substitute a type for the subtype and still be concrete and correct. So that's exactly what happened. We can just change something for a subtype of it, and actually, the file processor still works. Obviously, while we're on testing, this is the test that would happen for the concrete implementation. It's still ugly, of course, but there's a crucial difference here. This is what's called a boundary test. We've moved this to the outside of, or at least outside the logic, the business logic of our application. And there's a couple of consequences to this. That these boundary tests are isolated from the business logic. They will not change if you decide suddenly to, okay, I'm actually going to do SHA-256 or something. It will never change for that. It only implements that it's correctly implementing the interface. So does get files actually get a file? That's all it does. Which means that it will not change if the interface doesn't change, right? So that means that you don't need to run it every single time, probably, and that opens the door to actually using, moving to a maybe slower type of test suite that you can run in CI, and maybe not all the time, but you can maybe talk to the actual service, and that will ensure 100% that things will be working. So the second benefit of introducing DI is what's called lifetime, and again stems from the fact that we're passing something directly. We're in control of what goes into the file processor, and that means that the caller is in control of the lifetime of the concrete implementation. Therefore, you can actually reuse concrete implementations. So here, for instance, I'm instantiating one GCS file repo, and then we're reusing it on the file processor for 2 calls. That's something we couldn't do before, because before, every time you instantiated a file repo, it actually created a new client, therefore it had to authenticate again, and it's slower, right? So yeah, here I'm just pointing out that we're reusing the repo for the second file processor code. And the last benefit is composition. So it's composition in the sense that when you know for a fact what the file processor requires, like it needs a concrete implementation of that abstraction, you can create new implementations that extend functionality using a different implementation. So for instance here, creating a new concrete implementation that takes another one and filters it based on size. That's something you could not do before, and that's something very powerful as well, and also should think about, well, at least solve one concept, another principle, and it was the open-close principle, because the file processor is open for extension, but it's closed for modification. You can just compose these things without touching your old code, and it actually still works perfectly fine, because we've created this nice little abstraction there that enables all of these benefits. So while we're at it and solid principles, I'm assuming a lot of you know what solid principles are, but here's a rundown of the other ones that I haven't mentioned. Obviously, dependency inversion principle, we covered that. That makes sense. Single responsibility, we also covered that. And interface segregation principle is a little bit more, harder to explain on that particular example. But by sheer virtue of you creating an interface, you therefore are able to think about interfaces and start segregating them. I'm not going to get into the details of what that means, but it's sufficient to say that just by doing dependency injection and inversion control, you're opening yourself to a lot of the good concepts and good practices that you've been reading all along about object-oriented design. So this way of applying dependency injection, which is basically passing the instances directly to the classes, that's what's called pure dependency injection. And if you ever Google dependency injection in Python or any other language, you probably come across dependency injection frameworks. And they have a bad reputation because they're usually very complex, as they have a massive configuration file, and then you have to abide for all these rules. And the whole point of it is actually creating a composition root where all that dependency tree goes and it's solved for you. And it's good in a sense that if you have a very complex application and all of that work is done for you, but it's not required. And it's definitely not required. You can start using dependency injection right now on a subset of your application and it's absolutely fine. And that's I think it's one of the fallacies of dependency injection. Everybody thinks it's complicated, it's hard to pull off, but it's actually really simple and yields very, very tangible benefits. So where does it shine? It shines where the abstraction is very clear, and that usually means runtime dependencies and boundaries, right? It's obvious for anyone that if you're using GCS, you probably may want to use AWS, right? That's clear abstraction. Everybody understands that. There are abstractions in business logics, of course, but that are harder to come by or understand, because you need a lot of domain knowledge and you have to understand what's going on exactly. It's not as trivial, or at least it takes a little bit more time when you're trying to do it in business logic. And if you get those wrong, they're harder to backtrack, so you have to basically collapse that abstraction and try to get it right again. So, in conclusion, when you import an external library that does something, you should think about it and think about what responsibilities are you trying to fulfill. Abstract it if it's very obvious, and think about what exactly the abstraction needs to be. Again, tied to the responsibility is you're trying to fulfill. And you definitely do not need to go and import dependency injection framework and you spend months trying to convince people to use it. Just try it out in sections of your code and see how it affects your design. I think you'll find it will definitely help. So some further reading, because obviously I haven't covered all of you need to know about dependency injection. There's actually a book just for dependency injection. It's an excellent book. The examples are in .NET, which is a bit weird, but they're not that hard to follow because the concepts are simple enough and the examples are simple enough you can follow along. Then there's this book is 99 bottles of object-oriented programming. It touches upon dependency injection, but it's basically a book for object-oriented designing good patterns, starting with a very simple imperative code and actually making it. Sounds kind of silly, but it's actually a really good book. And the examples are in Ruby, so it's not that hard to kind of imagine how that would work in Python. And finally, the Gary Bernhardt's boundary talks is a classic, and just again touching upon how things are moved outside the to the boundaries of your application. It's a short one, but it's absolutely gold. So yeah, that's it. Thank you very much.
We've got 1 minute left if you'd like to take a quick question, if there are any. Okay, is there a quick question from someone? Do put your hand up, don't be shy.
So it's crystal clear, eh? No questions at all.
All good? Okay, thank you once again.
Thank you.